previous lecture, we have seen some numericals on the Fourier series where x belongs to uh, n pi and the interval is 0 to 2 pi. Now, in this lecture, we will see some question where the interval is minus 2 pi to minus pi to pi, okay, and x belongs to pi itself. So, we have a question where fx is equal to x and the given interval is minus pi to pi and we have also the same period 2 pi. So firstly, what we have to do, we have to sketch a graph for the function fx over the interval of minus 3 pi to 3 pi. So just simply scale it out in the graph first. Then what we have to do, we have to first make the graph for the minus pi to pi. So for minus pi to pi, it is fx is equal to x. So we have to just draw the straight line like that. Because for minus pi, the value of y is fx is minus pi. So it is minus pi comma minus pi. And for the pi, it is pi comma pi. Okay. Now, what we have to do, we have to just simply take this straight line and put it same in the manner for pi to 3 pi region and minus 3 pi to minus pi region because it has a period of 2 pi. Okay. So, as final, you will got the result as a three straight lines with each center as minus 2 pi, 0 and 2. Okay. Now, we have to find the Fourier series for that fx is equal to, as we know that for the Fourier series, we have to calculate a naught, a and then bn. So just simply use the formula a is not equal to 1 by pi integral over minus pi to pi. So here the function is defined over the whole series, so we don't need to break it. So after integration, you will got the value of a naught as 0. Okay. Now what we have to do, we have to then calculate the value of an. So for an, we have 1 upon pi integration with the limit of minus pi to pi and fx cos n pi. So here fx x, so we have to integrate it over x cos n. Okay. So after the integration, you have to use by part. So after integration, you will got first part in the form of this and second part you have to again integrate, which we have got sin n pi. And here as you can see, the overall interval difference is of 2 pi because pi minus pi minus minus pi is 2 pi. Okay, so we can directly replace it by 0. You don't need to solve full question. Okay, so now just simply put the limit in the first part and go. Okay, so after that, when we put the upper limit and lower limit, we will get this equation. And here you can see here the sin n pi is from and again sin n pi is from. And I already told you that whenever sin n pi will be there, you have to directly replace it with 0. So as this, the whole value of an will become 0. This is the value of an. Now we have to solve it for bn. So for bn, use the same thing. Instead of cos nx, we have to use sin nx. Okay. Then simply integrate by part. Then again you will got the same in the second integral part. You will get the cos nx integration over minus pi to pi. Replace it with 0. Okay. And for the first part, just put the limit and you will got this equation. Okay. And after solving this equation, at last you will got minus 1 by n 2 cos n. Okay. So already I told you for the cos n pi, it is minus 1 power n. So as a final, you will got the value of bn is equal to minus 2 by n minus 1 power n. Okay. Now, what we have to do, we have to just simply put the value of each an, bn and a naught in the fx function. So after that, what we will get, as you can see, a naught is 0, n is 0. So we don't need to focus on that part. We have to just simply take the bn sin nx. So for the each value of n is equal to 1 to infinite. So we have taken 2 by n as common. So sorry, 2 common, and what we have remaining then minus sin nx and minus 1 power n. So for n is equal to 1, this will give you sin x for upon sorry n, and for n is equal to 2, we will get sin 2x by 2 with the negative sign, because this alternative negative sign will be there. And then for the value of 3, then sin 3x by 2, and so on. So this is our Fourier series, okay, for fx is equal to x over the interval of minus pi to pi. Now let's take another question where we have given the interval which is break. So we have given a function fx where it is defined for minus pi to 0, the value of function fx is 1, and for the value 0 to pi, the value of fx is 0, and again it has a period of 2 pi. Now we have to draw a graph of fx in the interval of minus pi to 2. Okay, so simply first scale it out. Now what we have to do, we have a function which is defined for minus pi to pi. So just simply draw the graph firstly for minus pi to pi. Okay. So it is defined that fx is equal to 1 for minus pi to 0. So we will draw the horizontal line for minus pi to 0 as 1, and for 0 to pi we will draw the line at 0 to pi at the fx is equal to 0. Now we have to draw the graph for pi to 2 pi. So when you see that in minus pi to 0 region, if you add 2 pi, because we have a period of 2 pi, it means after adding 2 pi in any place, we will get the same graph. So if we add in minus pi plus 2 pi, we will get the value as pi, and in 0, if we add 2 pi, we will get the answer as 2. So we can replace this whole graph minus pi to 0 in pi to 2 pi region. And same for the 0 to 0 to pi, we have a fx is equal to 0, which is copy and pasted to the minus 2 pi to pi minus pi region. Because again, if we subtract minus 2 pi in both the coordinates, we will get the result for the minus 2 pi to pi. Okay. So after that, what we have to do, we have to find the closure series for that function. So first we calculate the a naught. Again, we have to remember, we have to break the limits of the integral. So we will not directly use minus pi to pi, we have to break it. So where the breaking point is at 0. So for minus pi to 0 region, we will use fx as equal to 1, and for 0 to pi region, we will use fx is equal to 0. Okay. Now after that, we have to just simply integrate it, and as you can see, the value of fx for 0 to pi region is 0. So don't need to solve it because it will always give you the value as 0. So just simply focus for the minus pi to 0 region. Okay. So what the result will cause 1 upon pi integration of minus pi to 0, and after solving it, we will got the value of a naught as 1. Now what we have to do, in the second step, we have to calculate the value of a n. Okay. And again, we have to use the same thing. 1 upon pi, we have to break the limit from minus pi to 0 and 0 to pi. So again, for 0 to pi region, fx is 0. So just neglect it. And for fx is equal to 1, we will solve the question. Okay. So now after solving it, you will get the value of a naught a n is again 0. Because in the answer we have got sin n. Now in the third step, we have to calculate the value of Pn, which is 1 by pi. Again, we have to break the limit as minus pi to 0. We will use 1, and for 0 to pi, we will use 0. Again, no need to solve it. Directly put 0 here, and for that, you have to solve. So after solving, you will reach at that point after putting the limit. So minus 1 upon n pi and 1 minus cos n pi. So again, cos n pi is replaced by minus 1 power n. Okay. Now again, this equation is same. So whenever you see this type of equation, what you have to do, you have to break it for n is equal to odd and n is equal to even. So here, if n is even, then what we got 1 minus, if n is even, the whole value of cos n pi will become 1. Okay. So for even n, it will cancel out and give you the result as 0. So for even n, we have the value of bn is equal to 0, and for odd, we have 1 minus minus 1. So it will give you 2. So we have got for n is equal to odd, we will get bn is equal to minus 2 upon n. Now we have all the values of a naught, a and bn, just simply put in the function fx. So a naught value is 1. So fx is 1 by 2. An is 0. So neglect that part. Now for bn sin nx, we have to remember that for even n, bn is 0. So no need to consider that. For only odd n, we have to remember. Okay. So just take minus 2 by pi as common because it is constant. So minus 2 by pi is common. Now we have sin nx by n, and where n is odd n. So just directly put 1, 3 and 5 like that. So for n is equal to 1, we will dot sin x. For n is equal to 3, sin 3x by 3. And for 5, sin 5x by 5, and so on. Okay. So this is the desired result for fx for the integration. So that's all for today. Now we will meet in the next video with some questions related to the x where x belongs to a whole number. I hope you all cleared your doubt. Thank you so much.